Let's do the extra practice problems for Chapter 1. Maybe that'll help. Number 1, how many significant figures are in the following measurements? Okay, A has 1, 2, 3 significant figures. Remember, they're significant if they are a non-zero digit, which are these two. If they're between two significant figures, which this 0 is between two significant figures, so it counts. And then the other way a 0 is a significant figure is if it's to the right of the decimal at the end of the number. So this 0 fits the criteria that it's between two significant figures. So this letter A, number 1, letter A, has 3 significant figures. This one is very easy. It's just 1, 2, 3 significant figures. This 0 is to the right of the decimal at the end of the number. And when it's in scientific notation, it's easy because you can just count how many digits are there. So there's 3 significant figures here. This one, these zeros are to the right of the decimal, and this one is at the end of the number, so it's significant. And then 0 between two significant figures is significant, making that one significant. So we have 1, 2, 3, 4 significant figures there. And then this one, these two are obviously significant. These zeros, this 0 is at the end of the number to the right of the decimal, that making it significant. So these zeros are also significant. These are not. They are not between two significant figures. They are not to the right of the decimal at the end of the number, which it has to be both. And therefore, there are 5 significant figures here. Now, if you were to put a 1 here, then all of these would be significant because they'd be between two significant figures. But that's not what he gave us. He gave us a 0 up there, and therefore there are only 5 significant figures here. Okay, number 2, what is the correct answer for the following equation? And we have 18 grams plus 1.6912 grams. This is the question. Now, when we add this up, it's 19.6912 grams. But following our significant figures rule, when you're adding or subtracting, you can only give your answer to the least precise of what you started with. And the least precise, this one is to the ones place, this one's to the tenths place. This is least precise. And therefore, our answer has to be to the ones place. So now we look at one digit past that, and that, because it's a 5 or above, that's going to roll this up. So our answer is going to be 20 grams. But we have to show that this 20 is actually significant to here. So you can do that one of 2 ways. How Jay Wiles did it is he puts it in scientific notation, which you can put a 1 here or not, and then grams. And what I showed you in class, because that's what they're teaching in some of the colleges now, is you could put this with a decimal here and then grams. That decimal to the right of that 0 is actually strictly there to show you that that digit is a significant figure. And so that would be an acceptable answer. Or if the college you're going to go to doesn't accept that, you can always write it this way, which shows you there's 2 significant figures. This answer is incorrect. It has too many significant figures in this answer because the precision ends at the ones place. Number 3, the length of a pin is 0.0258 meters. What is its length in millimeters? We want this in millimeters, so we're going to go times line. Whatever dimensions here has to go here, and what we want to get to we can do in one step up there, because we know that in every 1 meter there's 1,000 millimeters. And therefore, we're going to move this decimal place back 3, and that's going to give me 25.8 millimeters. So all I've done is just multiply this by 1,000. And the reason I did that is this will cancel, and I'll be left with millimeters. So 25.8 millimeters. Number 4, the mass of a stone is 56.1 kilograms. And we want to know how many it is in grams, so I'm going to go times line. Kilograms go on the bottom, grams go on the top. I know that in every 1 kilogram there's 1,000 grams. So I'm going to move my decimal place back by 3, so it's going to be 6,100 grams. I have 3 significant figures here. I have 3 significant figures here. This is obviously not in scientific notation here. If you wanted to put it in scientific notation, you would have written it this way. And so either answer would be correct. Number 5, the volume of a container, 0.005 kiloliters. We want to know how many milliliters this is. So it's a two-step process this time. I know whatever's here has to go here, but I know how to get to liters because liters is the common unit between these two. So that's where I'm going to go to. And then I'm going to go like this, and I'm going to put this here. Everything that's here always goes here. And now I can get directly to milliliters. In 1 kilometer, we know there's 1,000 liters. In 1 liter, there's 1,000 milliliters. And so this is going to end up being 5, and I'm going to move my decimal place back 6 times. So I'm going to do this. I'm going to show you. Okay, so I'm going to go 1, 2, 3, 4, 5, 6. So my answer is going to be 5,000. Liters cancel, kiloliters cancel, and I'm left with milliliters. I have one significant figure here. I have one significant figure here. And so that is an acceptable answer. Or you could have written it 5 times 10 to the third milliliters. Either way, one significant figure. Number 6, an object has a length of 3.45 meters. We want to know how many inches that is. Times line. Okay, I know we're given there centimeters. I'm going to write it here, 2.54 centimeters equals 1 inch. And we're trying to get to inches. So I'm going to take this to centimeters. So I'm going to put meters here, because whatever's on the top, that unit goes on the bottom so that they'll cancel. And I can get directly to centimeters. I know on one of this, there's 100 of these, don't I? And then I want to go from centimeters to inches, because that's what I was asked for. The 1 is with inch here, so it's going to be with it here. The 2.54 is with centimeters there, so it's going to be with centimeters here. That confuses some people, so I want to make sure you see it. We'll be left with inches, and so when you multiply this by 100, you're going to have 345 divided by 2.54, and that's going to end up giving you 136 inches, 3 significant figures, 3 significant figures. Remember, these have an infinite number of significant figures, so you don't want to go by that. Yeah, because what came out of the calculator is 135.826, blah, 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 blah. You needed 3 significant figures, so you looked at the digit just past that, and because it was a 5 or above, you rolled that up. And so that's how you got the answer there. Okay, number 7 says, convert the following measurements into scientific notation with 4 significant figures each. So we're going to go, remember, scientific notation, wherever the decimal is, you're going to take it back to where there's 1 non-zero digit to the left of the decimal. So we're going to have our decimal here. We're going to go 1, 2, 3, 4. So it's 1.7, and then he wants it to 4 significant figures, and so we're going to go ahead and do 0, 0 times 10 to the 1, 2, 3, 4. And it'll still be kilograms. So now we have this number written in scientific notation and in 4 significant figures. This one, scientific notation, we're going to go 1, 2, so we have 1.670 times 10 to the 1, 2, negative 2 meters, because this time we had started with a small number, and so we had to take our decimal 2 back this way to get 1 non-zero digit to the left of the decimal. Here, we're going to move 1, 2, 3 places, 8.761 times 10 to the 1, 2, 3, negative 3 milligrams. Once again, we started with a fractional number, therefore it's a negative exponent to the 10. And here, we're going to come back to here, 1.200, because we want 4 significant figures, times 10 to the second kilometers. And that tells me that's actually 120. So that's how you would express these in in 4 significant figures in scientific notation. Remember, scientific notation just moves your decimal so that there's 1 non-zero digit to the left of the decimal. And then once again, the question was to do these with 4 significant figures each. So that's what we did. There's 4 significant figures in each place. Remember, these zeros are to the right of the decimal at the end of the number, therefore they're significant, and so zeros between them would count as significant. Number 8. Convert the following measurements into decimal notation. So here, This is a positive number, so we're going to take the decimal place back 3 places. 1, 2, 3. So it's going to be 7,210 kilometers. Because remember, that 3 takes this back. I'm going to write it here so you can see it. 1, 2, 3 places. So I've moved the decimal place back to here. And that's what I did. Here it's a negative. So I'm going to rewrite this for you. We're going to write it 1, 2, 3, 4, 5. So we're going to put 0 point, and this would be where our decimal would go. 0, 0, 0, 0, 1, 1, 7. So there's my 1, 2, 3, 4, 5, which is what that called for. So I just took it the other way and filled in all the bumps with zeros. Here we have 8, so we have 3, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And I want you to see it. 1, 2, 3, 4, 5, 6, 7, 8. And then you put zeros in each of these places. Put your commas in, and you notice that's that number. And then this last one, I'm going to need room. And here, I'm going to put this here, and this is times 10 to the negative 7. So 1, 2, 3, 4, 5, 6, 7. There's your decimal place. So this is going to be 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And, oh, shame on me, that's meters, and that last one was kilograms, and that one's mils. You got to keep your units. I'm sorry I didn't do that. I should have. Keep your units with everything. Number 9, a container has a volume of 750 centimeters cubed. What is its volume in liters? 750 centimeters cubed. We want to know what it is in liters. We know that milliliters equals centimeter cubed, don't we? So we know that this is actually a straight one-to-one relationship with milliliters. And then we can go from milliliters to liters fairly easily, can't we? Because we know there's 1,000 milliliters in a liter. So that means we can rewrite this as 0.750. Whoa, can't write it that way. This has 2 significant figures, right? Because this 0 doesn't count. The way I wrote it there, that 0 is at the right of the decimal at the end of the number, so that would count as a significant figure. This has 2 significant figures, so your answer has to be in 2 significant figures, and therefore the answer has to be 0.75 liters. Got to lose that 0 because here it's a placeholder. It's telling you it's 750, but it's not a significant figure. It is not to the right of the decimal at the end of the number. It's to the left of the decimal. Number 10, a sample of liquid has a volume of 0.013 meters cubed. What is its volume in liters? We know that centimeters cubed equals milliliters, and that's going to be our bridge here, isn't it? So we have 0.013 meters cubed, and we are trying to get to liters, so we're going to have to go through this bridge. So we're going to go like this, and we're going to go, we know that for every, whoops, I got it backwards, don't I? There we go, meters to centimeters. We don't know the cube thing yet. We know that for every 100 centimeters we have in 1 meter, but we want this cube, don't we? So we're going to cube the whole thing. That's going to be 10 to the 6 centimeters cubed to every 1 meter cubed. Everybody sees, I just increased the whole thing. I cubed the entire thing. Okay, so that I'd have my meters cubed so that this would cancel. And that gives me 1,000,000 centimeters cubed. All right, so now we're up to centimeters, and I want to get to liters. So I'm going to go like this. I don't want to confuse you. So everybody saw how I got that? So now I'm going to put that in. So 1 meter cubed is 1,000,000 centimeters cubed. Now I can get rid of my centimeters cubed and go across this bridge, which is just a 1-to-1, and whoops, and then I can go to this bridge, right? And that would get me to my liters, and that's what I'm asked for here. is how many liters this is going to be. Okay, so now you just take your calculator and we lose that, we lose that, we lose that. We'll be left with liters, and we're going to, so it's going to be 13 liters. I see that because this 10 to the 6th will go down to 10 to the 3rd because of that. So times 10 to the 3rd, I'm going to move my decimal place by 3. So it's going to be 13 liters, 2 significant figures to start, 2 significant figures to end, and your bridges throughout. But remember, this one you had to figure out by cubing the whole thing. You started with the linear, which is 100 centimeters over 1 meter, and then you cube the entire thing. And that's how you got that part. Number 11, silicone has a density of 2.3 grams per milliliter. What is the volume of a silicone block that has a mass of 1.72? So we know 2.3 grams per milliliter. And we know that rho equals mass over volume, don't we? There you go. We know that rho equals mass over volume. And so, and we are told what is the volume. So we're looking for V. So I'm going to go V equals M over rho. All I did was multiply this by both sides, divide this by both sides, so that I got V by itself. We are told that the mass of this sample, is 1.72 kilograms. But I need this in grams, don't I? So 1.72 kilograms. I'm going to convert that to grams. And so that's going to be 1720 grams. That's still 3 significant figures. And then we're given the density in grams per mil. And so this is going to give me, he didn't ask it for a specific volume, so we're going to get it in mils because this will leave us with mils. So 1720 divided by 2.3. Now the answer that comes out of my calculator is 747.8 blah, 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 blah. Grams will leave and we'll be left with mils. But we have 2 significant figures here, 3 here. We're multiplying and dividing, so our answer has to be in 2 significant figures. So that means I can only go to that place. To do that, I look to the 1 digit next to it, which is between, it's higher than 5. It's either 5 or above. So that's going to make this answer 750 mils for it to be correct, because there's 2 significant figures here, so the answer has to be in 2 significant figures. What is the mass of a silicone block that has a volume of 0.45 liters? 0.45 liters. We want to know its mass, which is in grams, because we already are told in the previous problem that the density of silicone is 2.3 grams per milliliter. And because this is what we have, we're going to have to put that in milliliters too, aren't we? Okay, and so we want to know what is the mass. And we know that rho equals mass over volume. So we know that the mass equals rho times the volume. Rho, which is the density, is 2.3 grams per mil. And the volume we're given is 450 mils. We have 2 significant figures both places. So when you multiply 2.3 times 450, what comes out of your calculator is 103.5 grams, but I need this in 2 significant figures. That means it's got to go to here. That is below a 5, and therefore it's not going to roll up. So my answer is going to be 100 grams in 2 significant figures, which that's not. That's in 1. So you'd have to write this 1.0 times 10 to the second grams for this to be a correct answer, because that's giving you 100 in 2 significant figures, which is what the answer is because of the significant figures. Okay, this takes practice, but you're going to have to know this for the rest of chemistry. So please continue to practice your significant figures. Don't get frustrated. Just go over the rules, over the rules. Remember, when you add or subtract, you're going to go to the least precise to get your answer. When you multiply or divide, you just count how many significant figures are in what you're using. And whatever the least number of significant figures is, that's how many significant figures your answer has to be reported in also. So go ahead, study this, take your test, read the first half of the next chapter, and have a Jesus-filled week.